to get this in before the dog starts harassing me again. But in this video, you're going to start solving equations. And I think for this video, maybe going forward, but at least for this video, what I want you guys to do is write down the problems and the solutions as you go. So you're going to be more active learners in this process. Instead of just watching me do the problems, I want you to write down the problems and do them. So if that's after watching me do them, that's fine. If that's while watching me do them, that's fine as well. But please make sure that either on a separate sheet of paper or on the back or somewhere on a sheet of paper, you have the problems that I solved written down, just so we have a jumping off point, as well as to allow you to be more active learners in this process, so you're not just sitting and watching, because sometimes when you sit and watch, you start to zone out, and when you have to actually write stuff down, you don't zone out as easily, or I don't zone out as easily. Also, what you're going to notice is there's a whole lot of prior knowledge that comes into solving equations, like the introduction or reintroduction of additive inverse and zero pair and multiplicative inverse and identities, as well as operations with integers and inverse operations, period. So please be aware of all the different knowledge that you already have that you're going to be using to solve equations. So in this problem, this is just a two-step equation, 4 times x plus 2 equals 14. You're going to start by doing reverse PEMDAS. So you're going to start with adding or subtracting. So here, if you're adding 2, the inverse operation would be to subtract 2. What you do to one side, you have to do to the other. So the plus 2 minus 2, those are additive inverses of each other. They create a zero pair. So that zero pair is 0, so you don't have to rewrite it, but you bring down the 4x, you do 14 minus 2, which is 12, and now you get 4 times some number equals 12. You're going to divide by 4 because that's the inverse operation of multiplication, also known as multiplying by 1/4. So that's the multiplicative inverse. Dividing by 4, the same as multiplying by 1/4. Cross it out because that's going to be 1. Multiplicative identity tells us 1 times any number is that number. And x is going to be 3. Remember, you could always plug 3 back in for x and do 4 times 3 is 12. 12 plus 2 is 14. 14 does equal 14. You win. So now you have 1/2 times x minus 8 equals -2. So you're going to start with the adding and subtracting part because you're doing reverse PEMDAS. It's a minus 8. You're going to do the inverse operation, which is plus 8, therefore creating a zero pair. They go away. You're going to add 8 to the other side. You're going to bring down the 1/2 x, and -2 plus 8 is going to be 6. Integers are not ever going away this year, so get comfortable with them, just like fractions, and never going away this year. So now you have a 1/2 x equals 6. You can think of it as dividing by 1/2. Dividing by 1/2 is the same as multiplying by 2. And 6 divided by 1/2, be careful here. 6 divided by 1/2, if you go ahead and do that, would be 6 times 2, which would end up being 12. So if you go ahead and you say 1/2 times 12 is 6, 6 minus 8, -2, we win. Excellent answer. You walk away knowing you're correct. In this case, it's x divided by 3 minus 15 equals -20. You could also write it as -1/3 x minus 15 equals -20. Those are equivalent equations. They're the same exact thing. Dividing by 3, multiplying by 1/3, same thing. I'm going to do add 15, create that zero pair by doing the additive inverse. My zero pair goes away. X divided by 3 equals -5. Again, I could either multiply by 3, okay, or divide by 1/3. Either way, multiply by 3, divide by 1/3, same thing. If you don't believe me, get out a sheet of paper, do 6 divided by 3, okay? Do 6 times 1/3, same exact thing. These 3 divided by 3 is 1, so I can just write x. I don't have to write 1x, and that equals -15. If I put -15 back for x, -15 here, -15 divided by 3 is -5. -5 minus 15 is -20, and my left side, that is -20 equals my right side, that's -20, and I win again. So now it becomes a little trickier. So what I want you to do is when you're doing problems that look multi-step, more than just 2. So in the last 3 equations that we did, we had we had separate like terms. We had a constant that was alone, and then we had a variable And the problem, and you knew that you couldn't combine them because they weren't like terms. Now it gets a little trickier. You have two variables. I want you to kind of cover up the equals 9 and forget that it's there and simplify it as if it was like a regular expression. So you're kind of creating a wall, and the right side of that wall is not going to be there until you've simplified your left side so that you have a variable and a number. So in this case, you're going to box and circle, and you're never ever allowed to box and circle over the wall, but you are allowed to box and circle on each side of the wall independently. So you're going to add 1x plus 2x, and you're going to get 3x. The 3 has no friends on that side of the wall, and now you equal 9. So when you're focusing on one side of the wall, you're doing what it says. You're adding 1x plus 2x. You're adding 3. And now when you go to transfer that like term to its partner on the other side of the wall, the 3 to the 9, because you are crossing that wall, you must do the inverse operation. You are removing things from both sides of the equal sign. So the opposite of plus 3 is minus 3. Goes away. 0 pair, 3x equals 6. I divide both sides by 3. And x equals 2. So if I put 2 back in, 1 times 2 is 2. So 2 plus 4 plus 3. 2 plus 4 is 6 plus 3 is 9. 9 equals 9. I win yet again. Uh-oh, it's an even trickier problem. More combining like terms, but now I'm distributing. So I'm putting 31 to the side. I'm focusing just on 9 minus 2 times 3x minus 5. I distribute just like if I was doing an expression. I get negative 6x plus 10. I bring down the 9. That's going to equal 31, but I'm not worried about the 31 until I have a variable and a number left on one side. I'm going to box and circle. Okay, so the 9 and the 10 make 19 minus 6x equals 31. Remember, if you don't like the variable to follow the number and you'd rather have the variable first, you may rewrite it as an equivalent equation, which would be negative 6x plus 19 equals 31. Those are equivalent expressions. Equivalent equations. Either way, the 19 is positive and you want to move the 19 to be with the 31 because they are like terms and they are friends and they need to be on the same side of the equal sign. So in either case, I'm going to subtract 19 from both sides. When I subtract 19, on the right side I get 12. On the left side I get negative 6x. So notice the negative comes down. So I'm just going to go to another side here. So I'm going to have negative 6x, and it's going to equal 12. And the reason I brought down the negative is because if you rewind the video and you go back to the slide, there's a minus sign in front of the 6x. If you don't rewrite it as negative 6x plus 19, that minus sign has to come down. You divide by negative 6, and you end up getting x equals negative 2.